I'm going to review reading and writing chemical reactions and the 5 common types of reactions studied in Chem 1. Besides the formulas for the reactants and the products, other information can be provided in a chemical reaction. The physical state of each substance can be labeled using the appropriate letters in parentheses. An S for solid, an L for liquid, a G for gas, an AQ for an aqueous solution. Also, if any special conditions are required for the reaction to occur, this information could be provided above the arrow. Examples of this include the presence of a catalyst, heat being required to make the reaction occur, or a specific temperature or pressure necessary for the reaction to occur. In Chem 1, we discuss 5 common types of reactions. This is not an inclusive list for all of chemistry. Lots of reactions don't fit into one of these categories. These 5 are quite common, and they're relatively simple to understand, so we study these 5. First, synthesis reactions. Start with 2 or more reactants, which combine into one single product. Synthesis reactions are also called combination reactions. Here you see calcium and nitrogen combining together to make calcium nitride. Decomposition is the exact opposite of synthesis. Decomposition reactions start with one single reactant which breaks down into 2 or more products. Here, calcium carbonate decomposes into calcium oxide and carbon dioxide. Combustion reactions always have O2 as a reactant. Remember that combustion of a hydrocarbon is one type of combustion process. That type of process always produces CO2 and H2O. Combustion of an element is still combustion, but you're not going to get those kinds of products. You're going to get the combined compound between that element and oxygen. Single replacement reactions start with an element and an ionic compound. During the reaction, the element replaces the equivalent ion that's in the compound. A metal can replace another metal, for example. In this reaction, aluminum is replacing copper. Originally, aluminum is by itself and copper is in the compound, but a reaction occurs putting aluminum into the compound. We'll discuss single replacement reactions in more detail in just a minute. Our 5th type of reaction is double replacement. These reactions start with 2 ionic compounds, and during the reaction, the positive and the negative ions interchange. So in this example here, on the reactant side, cobalt is with nitrate and sodium is with hydroxide, and that all switches during the reaction. As products, cobalt is now with hydroxide, sodium is now with nitrate. We're going to discuss double replacement reactions more as well. So you have your 5 types of reactions here: synthesis, decomposition, combustion, single replacement, and double replacement. There's a great YouTube video that reviews the 5 types of reactions very quickly but very effectively. It's called 5 Major Chemical Reactions. Watch this and then you can practice labeling reactions.
There are 5 major classes of chemical reactions. A synthesis reaction is when 2 or more substances combine to form a single product. In a decomposition reaction, a compound breaks down into 2 or more simpler substances. A single displacement reaction is when one element takes the place of another in a compound. In a double displacement reaction, the positive and negative portions of two ionic compounds interchange. A combustion reaction occurs when a substance rapidly combines with oxygen to form one or more oxides and releases energy.
All right, now practice. For all of these, label the type of reaction and balance the equation. The answers will be shown on the next slide, so pause the video until you're ready to look over the answers. Please make sure you're able to recognize these 5 types of reactions. The first step in writing reactions on your own is recognizing what type of reaction will occur. So you have to know the unique characteristics of each of these types. Let's talk more about single replacement reactions. Remember that these reactions require the use of an activity series. There's an activity series for metals and an activity series for the halogens. Either way, it's a list of the elements in order of decreasing reactivity. Here's an activity series for metals. A reaction occurs when a free metal, that means the metal that's by itself as an element, not part of a compound, is more reactive than the metal currently in the compound. Here's the same example we saw before. Think of single replacement reactions this way. The compound listed as a reactant, it already exists, CuCl2 in this example. For a reaction to occur, to get a different compound, a, quote, better element must come along and make something happen to that existing compound. What's by itself has to be more reactive, or it can't bust in and break up the compound. So in this case, aluminum must be higher than copper for any change to occur. For the halogens, reactivity decreases down the column, so that's an easy activity series to remember. For the AP exam, knowing this general order will get you by. This is not completely correct. It is a general order. First, all of the representative metals come before any transition metals. This first bullet is entirely true. After that, though, there's actually some overlaps compared to these generalized statements. In general, Group 1 metals are before Group 2 metals, which are before aluminum. Then you have your transition metals. Row 3 transition metals, then row 4 transition metals, then row 5 transition metals. One exception to this that you do need to remember is that compared to this general order, copper is actually much lower. It's almost at the bottom instead of being up there with a lot of the other row 3 transition metals. So when you're given a set of reactants, how would you recognize that a single replacement reaction is going to occur? How would you recognize it as single replacement in the first place? You would look for an element and a compound where the element by itself is either a metal, hydrogen, or a halogen. Before you try to write the products, you must first decide if a reaction can occur at all using the activity series. For this first one, aluminum is the element currently by itself. The comparable element in the compound is silver. The element by itself, the aluminum here, has to be higher on the activity series than what's already in the compound, the silver, for anything to happen. So check that first. Is aluminum higher than silver? Yes. So this reaction will occur. Al will now be in the compound with Cl, and Ag will be booted out to be an element by itself. Remember, you have to write correct formulas first. Use what you know from nomenclature to always write compound formulas correctly. You can then go back and balance the whole equation. Here our products will be AlCl3 and Ag. And as I said, if you're asked to, you can then go back and balance the whole equation. A common mistake in writing products of single replacement reactions is to put the two comparable ions together in the compound, like trying to put Al and Ag together here. This does not happen. The elements you're comparing will switch places if the activity series says so. The comparable elements do not combine with each other, they switch places. Here's the second example. Use the activity series first to determine if a reaction occurs. Check Ag versus the equivalent ion in the compound, the Mg. The element currently by itself, Ag, has to be higher than what's already in the compound for a reaction to happen. Is Ag higher than Mg? No. So here, there's no reaction. Next example. Chlorine is the element by itself here. Compare it to the equivalent component of the compound. So that's the iodine. Is Cl higher than I on the activity series for halogens? Yes, it is. So write the correct formulas for the products. KCl and I2. Why does iodine have a subscript of 2 now? It's because it's one of the 7 elements that occurs naturally as a diatomic molecule. Make sure you have those 7 memorized and in your head. Last one, CuNO3 and Ca. What must be true for a reaction to occur? Ca must be higher on the activity series than Cu. And it is, so you write your products. CaNO3, 2, and Cu by itself. Moving on to double replacement reactions. These processes occur between 2 compounds in aqueous solution. Let's stop for a second and review a little bit of vocab. The solute is the substance that is dissolved. The solvent is the substance doing the dissolving. When the solvent is water, the combination is called an aqueous solution. The term aqueous is only used when the solvent is water. Otherwise, just call it a solution. One of several things must happen to drive a double replacement reaction. Either precipitate forms, a gas forms, or a molecular compound forms. If none of these happen, there is no reaction between the reactants that are listed. A double replacement reaction, and actually any reaction that occurs in solution, requires the use of the solubility rules when writing out the process. To say that a substance is soluble means that it will dissolve in water. We symbolize that with an AQ when we're writing the reaction. A substance labeled as insoluble does not dissolve in water. If it is a product that forms after mixing two compounds in solution, then it's called a precipitate. We symbolize insoluble components with an S because they're in their solid form. They're not dissolved. You must memorize the solubility rules. Make flashcards. Use an internet quiz site. Do something. You have to memorize the solubility rules. Given a set of reactants, you have to be able to write the correct formulas for the products and label the products as soluble or insoluble. Remember, what happens in a double replacement reaction is that the ions switch partners. So on the product side, we're going to have Al combined with OHs, and we're going to have Ks combining with SO4s. You have to be able to write these formulas correctly. So you have to look up Al's charge, you have to look up, or you have to know, actually, OH's charge. And you have to crisscross those and write the correct formula. That would be AlOH3. For your other product, when you combine +1 potassiums and -2 SO4s, you would get K2SO4. You have to be able to balance the equations. You can fix the ALs with a 2 in front of AlOH3. You can fix the SO4s with a 3 in front of K2SO4. And now a 6 in front of KOH fixes everything. Now, use the solubility rules to label your two products. The rule for OHs is that they are insoluble except for group 1 and group 2 from calcium down. Aluminum is not one of the exceptions, so it is insoluble, so we write an S. This is a solid precipitate. Don't assume anything about the second compound. A question can be written where both products are soluble or both products are insoluble. Any reaction can be written on paper. It may or may not represent an actual process that would occur. Use the solubility rules on each product. The rule for sulfates is that they are soluble except for calcium, strontium, barium, silver, lead, and mercury. Potassium sulfate, again, is not an exception. So this compound is soluble. We write AQ. Try this example. Nickel is going to combine with sulfur. Transition metals keep their charge during a double replacement reaction. So figure out the charge of nickel from its reactant compound and use the same charge when writing its product compound. Nickel has a +2 charge here, so its compound with sulfur will be NiS. KNNO3 make the compound KNO3. This one's easy to balance. All you need is a 2 in front of your KNO3. Now use the solubility rules to label your products. Sulfides are insoluble except for group 1, group 2, and ammonia. The exceptions don't include nickel, so nickel sulfide is insoluble. We write an S. Nitrates are always soluble, so write AQ for KNO3. Try this last example. Your products are KCl 2 up here, and a 3, and a 6. For state symbols, KCl is aqueous, barium phosphate is solid. Acid-base neutralization is a specific version of double replacement. This is where an acid and a base neutralize each other, creating a salt and water. Again, review your vocab. An acid is something that donates hydrogen ions to something else. A base accepts hydrogen ions. And a salt is any ionic compound that is not an acid or a base. These reactions are still double replacement, so you predict the products the same as before. The H and the OH give us our H2O. Mg and Cl make the salt, MgCl2 here. Remember, precipitate formation is not the only thing that can drive a double replacement reaction. This reaction is an example of formation of a molecular compound, H2O. Write the products for these reactants. The salt formed is Na2SO4, and we always get H2O. You can balance this equation with a 2 in front of NaOH and a 2 in front of your H2O. One more thing regarding acid-base reactions. It's not always a complete neutralization process. An acid and a base can react to create a new acid, called the conjugate acid, and a new base, called the conjugate base. A conjugate acid is the particle formed from the base. The base accepted a hydrogen ion and became the conjugate acid. The conjugate base is the particle that remains after the acid has donated away its hydrogen ion. So look at this example and label the acid, the base, the conjugate acid, and the conjugate base here. One technique for figuring out these labels is to pair up a reactant with the product it became. For instance, NH3 here became NH4+. What did NH3 do to become NH4+? NH3 gained a hydrogen ion. What type of substance gains hydrogen ions in reactions? Bases. NH3 is the base in this reaction. H2O becomes OH-. H2O donated a hydrogen ion out to something else in the reaction. That means H2O acted as an acid. The acid becomes a conjugate base. The base becomes the conjugate acid. Label everything in this example. HNO3 is acting as an acid. NO3- is the conjugate base. H2O is acting as a base this time. H3O+ is the conjugate acid.